Okay, so what we are doing for today, we are going to be focusing on addition and subtraction rules and how to work out addition and subtraction problems using number lines and counters as well. So our learning target for today, I can add and subtract integers using rules, counters, and number lines. So we're going to go quickly through the integer rules for addition and subtraction. The reason we're going to go quickly is because, again, this is something you learned in 6th grade. We're just going to work a little further on it. For addition, with addition, you've got 2 rules that you follow. The first rule is if they are the same sign. If you happen to have the same signs, then what you're going to do is you're going to add the 2 numbers together, and then you're going to keep the sign of the 2 values. So if they were positive values, you keep it a positive answer. If they were negative values, you would keep it a negative answer. So in this situation, we've got a -2 plus a -6. These are both negative. Both of these values happen to be a negative. So what we're going to do is we're going to take the negative sign out, and then we're just going to focus on doing 2 plus 6. What's 2 plus 6? 8. So then we get a -8. We add the 2 bases together, add the 2 base numbers together, and keep the sign of the bases. Same thing if they were both positive. So in this situation, both of these happen to be positive. So we know that we have a positive value, and we're just going to focus on combining the 3 and the 4 together to get ourselves a positive 7. Now, I don't have to write the positive sign in front of the 7. I'm just showing that to you for all intents and purposes. Okay, that's what you do if they happen to be the same sign and it's an addition problem. Now, they're not always the same sign. Sometimes they might be different signs. So if they are different signs, you're going to subtract the 2 numbers, and you'll subtract them just like normal. You'll take whatever your high number is and subtract your low number, and then you're going to keep the sign of whichever base is largest. Whatever the largest base is, you're going to keep that sign. Okay? Now, obviously, I had somebody tell me the other day, they're like, well, positive numbers are always bigger than negative numbers. We know that, but we're not talking about the sign, we're talking about the base. So in this case, 4 compared to 7, or in this one, 8 compared to 2. You're focusing on the base, not the sign. Okay? So in a situation like this, -4 and a positive 7 plus 7, those are different signs. So what we're going to do is we're going to subtract like normal. We're going to take the higher base. Which one of those is a higher base? 4 or 7? 7. And then we're going to subtract the lower base, which is the 4. Now, 7 being the higher base, I'm going to go ahead and put a star by it. It is my larger base. And was 7 positive or negative in the problem? Positive. 7 was positive, so I'm going to write down that this was positive, which means that my answer is also going to have to be positive. I need to make sure my answer will come out positive. And what's 7 minus 4? 3. So our final answer here is a positive 3. Okay, if I'm looking at the second problem, I'm going to go ahead and draw a little box here. I'm looking at the second problem. Again, I've got a -8 and a positive 2. A -8 and a positive 2, those are different signs that I'm combining together. So we're going to focus on doing the higher base minus the lower base. Which one of those is my higher base?
8.
The 8. So we're just going to put the 8. We're not going to worry about the negative sign yet. And we're going to subtract the 2. Now, again, 8 was the larger base, and was 8 positive or negative? Look back at the problem. Is 8 a positive number or a negative number?
Negative.
Negative. So I'm going to write down that this was a negative value, which means that my answer also is going to be negative. And then I'm just going to subtract like normal. What's 8 minus 2? 6, so my answer is negative 6. Okay, so once again, when you're adding your integers, if they are the same exact sign, if they are both positive or they are both negative, you just combine the bases and keep the sign. If they are different signs, meaning one of the values is positive and one of the values is negative, then you subtract it like normal, high minus low, and you keep the sign of whatever is your larger base, whatever your high was. You keep that sign. So if your high was a positive, your answer is a positive. If your high was a negative, your answer is a negative. Okay? Now, for subtraction is just as easy as addition because subtraction is addition. We do not subtract with integers at all. We do the additive inverse. That means instead of subtracting, you're going to add. And then what does inverse mean? What's another word for inverse? Opposite. Opposite. You're going to add the opposite. Additive inverse is adding your opposite. So you guys might have learned it last year as keep, change, change. But you need to know that it's called additive inverse. You are adding the opposite value. Okay? So what I'm going to do is I'm going to take my problem and I'm going to split it into 3 parts. I'm going to split it into the part that I'm going to keep, the operation, which is subtraction, and then my second number, what I'm going to change. So I draw 2 lines to split the problem into 3 components. Now the first thing that I'm supposed to do is keep. So I'm going to highlight the word keep in green. And underneath here I'm going to put a K to represent that I'm going to keep my negative 15 just as it is. The next word, change, I'm going to highlight that one in blue. I'm going to change, which means I'm going to change my subtraction. I'm going to put a C underneath it. I'm going to change subtraction into addition. So notice my subtraction sign now becomes an addition sign. And then I'm going to highlight the second change. Put a C underneath the 2, and I'm going to change that one to its inverse, to its opposite. What is the inverse of a positive 2? Negative 2. That becomes negative 2. Okay, so now we've got the problem negative 15 plus negative 2. It's an addition problem. So all you have to do is go back to your addition rules. Is negative 15 plus negative 2, is that a same sign or different sign situation? Same sign. These are same signs. So I'm going to follow the same signs rule. That means I'm going to add the 2 numbers together. I'm going to add 15 and 2 together, and I'm going to keep my answer what? Is my answer going to be positive or negative? Negative. We're going to add and keep the sign. So my final answer is negative 17. Camille, honey, I need you to focus on what we're doing up on the board. Okay? I'm going to rewrite this one off to the side so I have more space. This was negative 5 minus a negative 4. Okay, so again, we do not do subtraction. We change our subtraction problems into addition problems. So we split this into parts. We've got the very first part, which we'll keep, the middle part, which will change, and then the last part, which will change. So we're going to keep the negative 5. We're going to change subtraction into addition. And we're going to change negative 4 into its inverse, positive 4. Okay, so it's an addition problem now. Are these same signs or different signs? Different. These are different signs. So because they are different signs, I'm going to follow my different signs rule. That means I'm going to actually subtract them and keep the sign of the larger base. What's my base? Which base is largest? 5 or 4? 5. So we're going to do 5 minus 4, and the 5 is the larger base, which happened to be a negative. So that means my answer is going to be a negative 1, because 5 minus 4 is 1. So I get a negative 1 as my answer. Okay, what I want you guys to do, without a calculator, you are not going to use a calculator right now. Without a calculator, you're going to do problems 1 through 6. After you've worked through problems 1 through 6, then you will check your answers with the calculator. You do not use the calculator the first time. You will check after you're done. Okay? Okay, let's go through this very quickly. So for problem number 1, we have -7 plus 2. These happen to be different signs. So I'm going to put that they differ, which means I'm going to go ahead and do 7 minus 2, and I'm going to keep the sign of the 7, which happens to be the negative, and that's going to come out to a -5. So for problem number 1, you should have gotten -5. For problem number 2, I'm adding, and they happen to be the same signs. So that means I'm going to keep the negative for my answer and just focus on adding 4 and 5 together. That's going to come out to a -9 for my answer. For problem number 3, this is a subtraction problem, so the first thing that I need to do is I'm going to keep, change, and flip. I'm going to keep the first number as an 8. I'm going to change the subtraction into addition, and then I'm going to change the -4 into a +4. They happen to now be the same sign. Since they are both positive, my answer is going to be a +12. Problem number 4, again, they are subtraction. So I'm going to split this into the parts, and I'm going to keep my -9. I'm going to change, oops, sorry, that was supposed to be in a green. Keep my -9. I'm going to change to addition, and I'm going to change to a -2. So I now have -9 plus -2. Again, these are going to be same signs. So I'm going to keep the negative and just add the 9 and the 2 together, which is -11. Problem number 5, it's an addition problem, and they are the same sign. So I'm going to keep the negative and add the 3 and the 11 together to get -14. And then for problem number 6, it's a subtraction problem. So I'm going to split this up into the parts. I'm going to keep the 7. I'm going to change to a plus sign, and I'm going to change to a -15. So I have 7 plus -15. These are different signs. These are different signs. So I'm going to do 15 minus 7, and the 15 is my larger base, which happens to be a negative. So my answer is going to be a -8. Okay? Any questions? Go ahead and flip it on over to the back then. Let's move on to some word problems. Remember, it's important to understand your vocabulary that indicates positive or negative terms, but you also need to understand your vocabulary that indicates whether you're dealing with addition or subtraction or multiplication or division later on. But we're focusing on addition or subtraction today. Okay, so for problem number 1, it says Mount Everest is 29,028 feet above sea level. So right there, what kind of value, positive or negative, am I talking about if it's above sea level? Elijah? Positive. We're talking about a positive value. So I'm going to go ahead and highlight that in green so that I know I'm dealing with a positive number. And then it says the Dead Sea is 1,312 feet below sea level. What kind of value is that, Gal? Negative. So the Dead Sea is below sea level. That makes it negative. Now, we have an operation term. There is a term up here that is indicating an operation. That term is difference. What operation does the word difference mean? Asher? Subtraction. So I'm going to go ahead and write down that this is supposed to be a subtraction problem. So I'm going to be subtracting Mount Everest minus the Dead Sea. I'm going to subtract Mount Everest minus the Dead Sea. I'm going to go ahead and put my subtraction sign here because the number one mistake that people make is that they forget their negative sign because they wrote their subtraction sign and immediately think their subtraction sign is already a negative sign. But subtraction and negative are different symbols. Okay, they look the same, but they mean different. So for our Mount Everest, we're at 29,028. And then we're going to subtract Dead Sea. Dead Sea was at a negative 1,312. So I have a subtraction sign for the difference, and I have a negative sign because it's below sea level. Okay? And then we're just going to go ahead and subtract. We're going to keep, I'm going to just do this all in blue right now, or actually, no, we'll do it. We're going to keep this as 29,028. We're going to change to addition, and then we're going to change to the opposite, 1,312. Then we can combine those together. When I add those together, from keep, change, change, I'm going to get 30,340 feet. That's how far apart those two elevations are. I want you to try problem 2 on your own. Try problem 2 on your own. All right, let's go ahead and go over this. In Denver, the temperature in the morning was negative 18 degrees Fahrenheit, so it's already told us it's a negative. By the afternoon, the temperature rose 12 degrees. What's the temperature? Okay, so we want to know what the new temperature is. So we're given an original temperature, which was a negative 18. Then we're given an operation. It rose 12 degrees. So what does the operation rose indicate? Well, increase is not an operation. That's just another word. What operation is it? Add. Add. This is addition. We are going to add. So we're going to put addition, and we're going to add the 12 degrees to it. Okay, so we have negative 18 plus 12. These are different signs. These are different signs. So because of the fact that they are different signs, we're going to subtract it, 18 minus 12, and we're going to keep the sign of the larger base. What sign is my larger base? Negative. My larger base happened to be negative, so when I subtract, I'm going to get a negative answer. What's 18 minus 12? 18 minus 12, guys? 6. So we get negative 6 as our answer. It's negative 6 degrees after it rose 12 degrees. Okay, we're going to stop here for today. If you did not finish your IXLs earlier, you get the rest of class period to do so. Those of you who are done with IXL, you should be navigating over to Prodigy Game because Prodigy Game has a diagnostics that it's having you do right now. So if you finished your IXL, go to Prodigy Game. If you have not finished IXL, finish your IXL.